All right, awesome pre-calc students. This is 7.6. This is the last section in chapter 7, and then we will soon have a chapter 7 test, okay? So keep that in mind. Before I give you all of the identities for the double angles, I'm going to prove it first to see how or why we have what we have, or we are using these formulas, okay? So the first thing is I'm going to write an identity that you already know, such as sine of alpha plus beta, okay? So right now, can you do me a favor and give me that identity? What is sine of alpha plus beta? Okay, so did you write down sine of alpha cosine of beta? Because it's an addition of sine, I'm going to add here. Oopsie. And then I would write sine. Well, actually, I think I normally write cosine first, right? So cosine of alpha sine of beta. And it doesn't really matter, okay? So what if, if alpha and beta are the same, okay? So what I mean is that let alpha be theta and also let beta be theta, okay? So this means alpha is the same as beta because they're all what? Theta. So what I'm going to do is I'm going to substitute this in, okay? So sine of alpha now is theta and beta is now theta. So I'm going to write, every time I see alpha and theta, I will now use, every time I see alpha and beta, I will now use just theta, okay? So, and yes, in mathematics, what we do is we manipulate one equation to come up with another, okay? So in here, sine of alpha plus alpha is now sine of, not alpha, I'm sorry, sine of theta plus theta is now sine of 2 theta, okay? Equals to, well, would you agree that sine of theta, cosine of theta, in over here, I can write sine of theta in the front, right? Because addition is commutative, and so is multiplication, okay? So because multiplication is commutative, that means I can move things back and forth. So would you agree I can combine these because they're exactly the same? So sine of 2 theta is 2 sine of theta times cosine of theta. And guess what? This is a new identity, okay? So new identity, highlight, and let's write this up here, okay? And yes, that's how they come up with one new identity. They manipulate the equations that's already known. All right, so sine of 2 theta is called double angle formula because instead of 1 theta, it's now 2 theta. That's why it's called double. So here's our first identity. Sine of 2 theta is always 2 sine of 1 theta times cosine of 1 theta. So that's how they came up with the double angle identity for sine, okay? So now we can also work with cosine, okay? I'm gonna use different ink. All right, so I'm gonna start out with the same thing, cosine of alpha plus beta. Okay, do me a favor and write down that identity, please. Okay, so let's say cosine of alpha, cosine of beta. In cosine, the signs are opposite. Sine of alpha and sine of beta. So similarly, I'm going to manipulate this the same way, okay? We're going to make alpha and beta the same, okay? So let alpha be the same as beta, and let's all call it now theta, okay? And yes, in mathematics, you can do that. So what if that's the case? Then now I would have cosine of alpha is now theta, so is beta, okay? So every time I see alpha and beta, I will now put in theta because That's what I assume over here. So sine of theta times sine of theta. Well, cosine of theta plus theta is now cosine of 2 theta. Okay, see how the double angle is coming around? Equals cosine of theta times cosine of theta is now cosine square of theta. Okay, minus sine square of theta. Okay, all right, so guess what? This is our identity for cosine of 2 theta. Isn't that beautiful? Let's write it up. Okay, cosine of 2 theta is cosine square of single theta, take away sine square of single theta. But with cosine of double angle, we can also manipulate this, okay? Remember this identity that we had before. So identity, right? Sine square of theta plus cosine square of theta equals 1, right? So would you agree that I can cosine square of theta equals 1 minus sine square of theta? So what I can do with double angle identity is I'm going to create different one just based on other things that we already know. Every time I see a cosine square, I can now put in 1 minus sine square of theta and then bring this down, minus sine square of theta. So cosine of a double angle is, here's another one. Now, these all come from the original, okay? But sometimes one is easier to use than other, so that's why we want to write all of these down. So let me write this one down, okay? And I want to write that in red because that's cosine of a double angle. All right, so it's 1 minus 2 sine square of theta. Okay. Now, well, technically, I don't really have to substitute in cosine square. I can technically substitute in sine square. Would you agree? Sine square of theta equals 1 minus cosine square of theta. Okay, so I'm going to do the same thing, right? I'm going to take this, what we already know, okay? Cosine of 2 theta equals, I'm going to keep cosine square of theta, but substitute in sine square is 1 minus cosine square of theta. Then from here, cosine of a double angle is, distribute the negative sign to see what I have, minus 1 plus cosine square of theta. Combine like terms, cosine 2 theta equals 2 cosine square of theta minus 1. Guess what? This is another identity for cosine of a double angle. So if you can see, cosine of a double has 3 different equations, okay? Oopsie, I meant to use red. All right, so here's another one. Cosine of a double is, now, do you have to memorize all of this? Yes, okay. But if you don't, like on the test, if you don't have it all memorized, technically, can you go and like derive it from original or from scratch? Of course, okay. So if you get stuck on the test and don't remember what to do, just start from scratch, okay? All right, we got sine of a double, we have cosine of a double. Guess what? We can also do tangent of a double, okay? So what would I do with tangent of a double? I'm going to do the same thing. So I can also manipulate tangent of a double. Tangent of a double, though, it's gonna be a little bit longer, so I'm just gonna give it to you. Okay, are you ready? I'm gonna use a different ink. How about green? So tangent of 2 theta is, in your book, I'm gonna give you 2 tangent of theta, and should I do this with you from scratch? Maybe I should, huh? Okay, let's start from scratch. That way you can see where this comes from. All right, so just like the other ones, okay, I'm gonna start with you from scratch. Are you ready? So tangent of alpha plus beta equals to tangent of alpha plus tangent of beta all over 1 minus tangent of alpha times tangent of beta. And again, let alpha be exactly the same as beta. which let's call it now theta. So tangent of theta plus theta is tangent of theta plus tangent of theta all over 1 minus tangent of theta times tangent of theta. Then from here, can you see what's going on? Why don't you simplify that for me? Do you see where tangent of 2 theta comes from? Tangent of theta plus tangent of theta is 2 tangent of theta. Would you agree? All over 1 minus tangent times tangent is tangent square of theta. So that's where they came up with this double angle for tangent. Okay, so that is how we came up with all of our double angle identities. Now, do you need to know this? Do I need to memorize this? Oh my goodness. Yes, yes, yes. Memorize, please. Okay. I would not give you these at all on your test, so make sure we know where or how or what the double angle identity